to the lecture series on soft computing in computer science. In this lecture, we are going to see application of backpropagation neural network. Very particularly, this presentation will dealt with application related to diabetes data. So, in my earlier presentation, I have discussed much about the MATLAB code development. We started the MATLAB code development for the BPN model with the support of iris data to classify the iris flowers into 3 different categories. Later in the next presentation, we entered into an engineering application, particularly network security domain. The task is going to be detection of intrusions, where the intrusions has been identified with respect to their categories of attacks. This presentation I am going to discuss about a healthcare domain specific problem, that is prediction of diabetes through data. Let me explain what is diabetes. So, it is a very common one that is prevailing among many of the people nowadays. It is a kind of metabolic disease which may come because of the defects in insulin production, insulin action, or both. So, that is the major cause for this kind of disease. If this disease without any proper treatment, it may lead to various complications like cardiovascular disease, chronic renal failure. Sometimes eye get affected and the severity is called as a diabetic retinopathy. So, those kind of stuff. So, identification of the disease causing agent, the biomarkers or the variables responsible for diabetes is the crucial one. So, what is the difficulty that is faced by the physician? Even though there are lot of physical controls are available, the collection of much information related to diabetes is very crucial as well as very challenging. Why? Because it is having the parameters from many sectors of our human body. Sometimes the data may be of diversified in nature, which may not be exactly related to the finding of the disease. So, doctors in general finding very difficult in order to understand the disease pattern as well as behavior with respect to the data. So, one technology have come into existence. That technology is called microarray technology, using which we can read the genetic expressions. From the genetic expressions, we may came to know which are all the genes that are responsible for causing these diabetes. Actually, this microarray is a technology that measures the expression level of thousands of genes in a sample of cells. So, the gene expressions with respect to a healthy cell as well as the non-healthy cells will give you a promising information. Using that, we can use it for we can go for any kind of disease prediction with respect to genetic level. Nowadays, this technology is enormously used. Of course, this technology is recently not that much used. The next to advancement of this technology is NGS, next generation sequencing analysis. Those kind of stuff has been come into picture. Mostly this kind of technology has been studied by some wet lab, by the bioinformaticians as well as biochemistry people. It involves various chemical related process, and it has been displayed in this picture. Thanks to Google for sharing this picture. So, here though many information has been many chemical process as well as biochemical process has been happened in order to generate the data. The data that has been generated is a kind of image. It is a kind of image. So, that image is the one that is responsible for creating the microarray data. So, the genes that has been expressed, the intensity level of the gene that has been expressed has been recorded So, if you could see that when respect to a microarray data, the number of genes is enormous amount, that is treated in general as 1 to m, the n may be enormous. And the number of samples being the genetical level, the patients or the subjects prone to this technology is very minimum, and the number of samples, sample 1 to n, it is very lesser in this situation. So, the data is we look at it, this is the various technology of bioinformatics based or biochemical based process, out of which the data has been generated. So, it is in the form of sample, that is in the row wise, and the gene is in the column, and the final category is the category of the disease, whether it is a disease or it is healthy. So, in that case the data will be presented to the researcher in order to go for further development of the AI based models. So, this diabetes microarray data, if you look at it, this particular data taken for the discussion of the application consists of 34 samples with the number of genes as 22,283 genes, and the 2 class labels, one is diabetes mellitus 2 and normal glucose tolerance DM2 and NGT. Both the cases have 17 samples each. So, you could see that the challenge posed by the microarray data is something different, low sample and ultra high dimension. So, the dimension is not 100 or 200, it is in the form of thousands, 22,000. So, imagine what is the factor that decides the number of nodes in the neural network model. Number of input variable will decide the number of input nodes. So, how many input variables are here? 22,283 input variables are here. So, imagine how many input nodes that you have to have, 22,283, and how many output category? 2 output category, DM2 and NG2. So, one node is sufficient. If it is produces 0, then it is DM2. If it is produces 1, that is NGT, like that we can, only is sufficient. So, normally people will get confused, sir, 2 category labels are there, so why can't I go for 2 nodes? So, that is not needed here, because it is a binary units, it may produce 0 and 1, because it produces 2 different values. So, for one value you can assign one category, and for the other value we can assign another category. So, that is the way you can make use of the one output node for this kind of problem. And if you look at it, the data, it is looking like gene ID as well as sample number. So, each gene ID will have a specific ID number, and it has an expression values, that is nothing but the intensity value. So, the ID is the one which represents a particular gene that are responsible for a particular function. If any disturbance in the genes has been occurred or any malfunction has been happened, so definitely that prone to a kind of disturbances in the human body, and they may lead to the disturbance of the normal functioning of the human organs, and which in turn lead to a particular disease, very particularly this particular kind of hormonal based or lifestyle based diseases. So, this is very particularly measured with respect to a microarray technology, and the data has been produced. But it is the responsibility or the duty of the physician to analyze the data in order to come with a definite conclusion. But analyzing this vast amount of data is a very challenging task. So, we can seek the help of any AI based models, and here is the example of how the ANN model is very much useful for analyzing this microarray data in order to say whether the individuals is having a disease or not. So, let me discuss the implementation with respect to the MATLAB software. So, if you look at it, the MATLAB environment, so I have something called diabetes data. See, this data is here. If you look at, so how many, okay, if I come down, see how many sample sizes are 19,319. So, actually 22,283, maybe some redundant or some missing value or some anonymous, that is maybe some symbols are available in some genes that is not possible for us to load. So, those, after removing those kind of unnecessary records or unwanted records, we may reach up to 19,319 genes. Since all these things are not loaded in the row and column wise, the transpose is loaded here, transpose of the matrix is loaded here. So, the gene ID is here, and at the end you may have a class label whether it is having disease or not, like that. So, this is the complete data of the type 2 diabetes that is especially taken from the what is that microarray technology data. So, like NCBI, like the UCI machine learning capacity that is used to download the IRIS or any other benchmark data, this can be downloaded from a website called NCBI, National Center for Bioinformatics, which is very easier to download this kind of data. So, that this data is very helpful for analyzing the diabetes data. So, this data can be downloaded from there, but if you look at that NCBI, you cannot get a clear picture of what exactly the data is. You need to do lot of data modifications, data arrangements, for which you need support from other domain people. So, with the help of those bioinformatics people or biochemistry people, those who are well versed in that domain, so the data is prepared in such a way that which is very easy to fed to the ANN model. So, this is the model that is very essential in case of ANN. This is the data. Now, I will load the program. The program is this one. So, in this program what is did actually is, see, as usual the practice is using these 3 statement CLC, clear all, close all for doing the preliminary task. See, the data is loaded using the load command and it is assigned to a variable I here stands for input. So, now the input variable something has been removed, that is ID has been removed, it is not required for analysis, only the expression values are needed. So, the ID has been removed, and the some values like IGT that is what is that some category, 18 to 25 is one category, one class, and 35 to other is other category. So, those 2 categories are categorized as 2 different one. So, the input is created in the variable I, and O, it is mentioned as O output variable, and 1 to 17 is the first category and 18 to 34 is the second category. So, likewise the class labels are also assigned. So, now we are ready with the data, rather than using x and y and x1 y1 x2 y2 like that kind of practice. Here I introduce using the variable I and O for input and output. So, it means that you can use any variable name for your convenience. So, it is not necessary you can use x and y, right. So, here one thing is there, gene selection. So, this task is very essential task with respect to data mining as well as with respect to machine learning context. What is that is, when you want to include all the data for the model development, there might be a scalability issue, or the model is not working well, or the model development is highly complex as well as challenging. So, instead of utilizing all the data, so how many data are here? See, 19,000 data approximately, right. So, all these data you can have to create 19,000 nodes. So, and the computation is very time consuming, as well as it maybe some your system may get stuck if you use all those nodes for computation purpose. So, normally as a data mining perspective, what one can do is one can go for dimensionality reduction. Very particularly this is a structured data. So, very particularly one can go for feature selection. Feature here refers to genes, because we are working with the genes, right. So, gene selection has been carried out, and in this particular application, gene selection has been carried out using a simple machine learning statistical based algorithm, that is correlation coefficient. Using correlation coefficient, the genes that means the input features are ranked according to the higher ranked variable. We have considered only the few numbers. I think in this experiment only 10 variables have been considered. Yeah, yes, only 10 variables has been considered for the input variable. See, Fi, that is feature input, is 1 to 10. SF is the reduced features. I think it is treated to 1 to 10. So, 10 input features has been selected as the thing. So, how many number of input variables? 10 input variables. And how many number of categories? It means 2 categories, DM2 and NG2. So, the major task involved here is the correlation coefficient, that is identifying the important genes, but that is not the factor. Once that has been done separately or it has been inclusively included into the ANN model development, somehow you have identified the input variable, then this process is same, right. So, you have included all the things, you have divided the testing and you have made, see here you have created the training input and you have made the training input and you are making the testing input and you are creating the testing output. So, doing the normalization and doing the normalization of the testing data. So, everything is the general process. See, the same code that has been modified. So, until here it differs from application to application, because application to application we receive different kind of data and each data has posed a different kind of challenges. According to the challenges prevailing in the data, according to the way in which we have to make ready the data with respect to ANN model development, we need to do some lipstick works in order to make the data very pakka to use it for the ANN model development. So, this is the code, and this portion of the code, again I am saying normalization. After normalization, this portion of the code is the model development which comes with the help of a new FF, init, then what is that, yeah, train and followed by sim. So, those 4 commands are used for doing the same purpose. And here if you could see that what is the number of hidden node is 3 hidden nodes is used, number of output node is 1, I already said, because only 2 output. So, 0 for one case and 1 for another case. So, after that you got the actual output y with the help of the sim command, and then we have to calculate the error value based on that it has been propagated, the weight values has been updated, and finally the threshold, with the help of the threshold you can arrange the values in order to get S as well as A. S is simulated value and A is actual value, and you need to have a proper comparison and according to the proper comparison wherever the success is there, you have to increment the counter in order to say the correctly classified data. So, this is the way in which you can modify the IRIS program in order to suit for the diabetes data classification. So, the workspace is empty now. Now, I will use I will run the program so that you can understand the what is the thing that is happened here. So, this is the correlation value of various genes, the experiments are executing it. So, maximum 100 epoch is meant and it will take only 41 epoch, because we have only 10 input variables. So, in the case of intrusions detection we have 41 input variables. Here also we have enormous more huge number, but we have reduced according to the correlation. Let me discuss the correlation result first. If you look at the correlation result, I think that window has been overwritten. Okay, no problem. So, this is the results that you can get it. In network diagram you can see how many nodes in the input layer and how many nodes in the output layer. See, there are 10 nodes in the input layer, hidden nodes there are 3, and output you have only 1 node. The performance curve, if you could see that it has meet out the performance. See, it has been a drastic change. See, whenever you choose an application specific data, the curve is not specific smooth, it might be a random one, because the data has such non-linearity as well as multimodality is there. So, this is the one that we are expecting actually for real time applications. If the data is uniformly distributed and it is been executing it well, you may get a smooth curve, but sometimes you may have this kind of curve, right. About 41 epoch it reaches the goal of 0.01 and the execution process gets stopped, and finally what we got is, yeah, we got 100. So, we have only 17 samples for testing and 17 samples for training. So, I think redundant samples as well as the missing value samples have been removed. So, totally 14 samples have been taken for testing. Out of the 14 has been classified as we have got. So, this is happened sometimes if you give enough amount of values to the one, but when you go for some writing papers and all using this kind of results, definitely they may say that the data is insufficient. So, number of subjects should be enormous. So now you cannot say that I have obtained 100% accuracy, so I can use this AI-L model for detecting the diabetes. I can deploy the model for real time purposes and all. It is not that much having the valid point here, because this is such a simulation in order to understand how it can be used. So practically speaking, when you go for real time, you need to increase the number of samples. Here we have only 34 samples, so you try to increase the number of samples. The number of samples should be large enough so that it has to incorporate all the new and unknown cases, and it will be ready for any unforeseen kind of data. So it will be effective enough for producing the results. So this is the way you can develop the model. And one more code that I have, this is for breast cancer data. See, this is data that has been downloaded from UCI machine learning repository. See, if you could see that the number of input variables are 11 input variables, 11 variables. This variable sample code number is just a constant, we need not bother about it. So these are clump thickness, uniformity of cell size, uniformity of cell shapes. So this number mitosis up to that level. So the ranges are between 1 to 10, all the variables are ranges between 1 to 10. These are the input variable, and the variable is 11th variable, that is the class variable, 2 for benign and 4 for benignant. You can change the value, 0 for benign and 1 for, so I have changed the value here like that, 0 for, so this is the output. So this is the breast cancer data. For this data we can use the model development, that code. So this is the code. So we could see that this CLC clear all is a standard practice. So loaded the data. See now the variable how it is formed, input, instead of having the variable xy, input, output. So training input, like straightly the variable name is given like the training input. So training output. See how 1 is to 2 is to 683. So there are 683 samples. So from first record to 683 record, every 2 records the data has been taken for testing. Accordingly you have to think like that. So testing input, test output, so all these things. After that what? Data normalization, then creation of network structure. If you could see that the creation of network structure, you should have the parameter of identifying the deciding the number of hidden neurons, as well as number of output nodes, and you have to design the new feed forward neural network, that is new FF method, like here. Then you have to use the init model to init the network, then followed by train and as well as sim command. So those all these efforts. Then using the threshold you have to divide the data into 2 different categories, because the neural network model will provide a decimal fractional value, that is continuous value, that has been changed to a particular category. So then the visualization of output with respect to 2 variables, simulated as well as actual. So S and A. So that is happened there. So all these steps as usual, the general procedures, then you can do it. Now in the command prompt itself, we can give the CLC command in order to erase the results that has been displayed for the diabetes. See, all the results have been displayed. Now if I use clear all command, so what has been happened? The values in the workspace, see these many values are, what are these values? These values are values obtained for the simulation of the diabetes data. So if we do that, so all those variables has been erased. Now the workspace window will become empty. Yes, now the workspace will, now your environment is completely ready. Now we can execute the breast cancer code. So the breast cancer code I am going to execute. So 1200 epochs. So up to 670 epochs the program get executed. 670 epochs the program get executed, maximum of 1000. It has been achieved the performance of 0.009. So the goal is 0.001. So it has achieved the result. So we could see that the classification accuracy is the number of correctly classified data is 327. So mean square testing error, mean square training error, as well as these are the basic requirements one has to want. After that you can go for receiver operating characteristics curve, ROC, confusion matrix, precision recall. So those kind of steps we can little bit go on with by analyzing the data one by one, like true positive, true negative, and everything we can do it. So that's all about the MATLAB code development for breast cancer data. And until now we have seen 4 different categories. One is iris, another one is intrusions, diabetes, now the breast cancer. See, all these 4 belongs to a kind of problem called data classification problem. The task is a classification task, but we have another task called regression also. This BPN model is very good at doing regression also. So, the same code can be used for regression, but only the small change in the last part. So, let me discuss those idea also, for which I have taken a data called body fat data. So, this data is meant to predict the fat level of the human body. So, also this data is available in the UCI machine learning repository, where the iris data has been taken. So, in this data you have 13 input variables. See here, if you look at it, 13 input variables. So, 13 input variables are given, and the output variable is only one variable, because it is going to give the what is that singular value, that is a continuous value, that is a fractional value. So, those values are given in the last column. So, this is the complete data. The last value is the body fat, maybe you can say that body mass index, like that, right. So, 12.3, 6.1, 25.3. So, for the person whose age is this is age is 23, weight is 154.25, height is 67.75 inches, neck circumference is 36.2. So, like that. See here, the variables values are given, right. So, accordingly the values are. Now, the same, if you want to create it into a data code, the same code. So, the standard practice of CLC, clear all, close all kind of stuff, loading the data, assigning to the variable xy, dividing the data into x, y. So, so and so things are the standard practice, everything do, normalization, network structure creation. So, everything is there. Where is the modification is, here is the modification. So, this is the regressor equation, where it has been used to. So, from the mean square error as well as the value that we got, that is y, this y is the simulated output. So, from this y you have made that regressor equation in order to make the prediction point for this body fat data. So, let me execute this. So, before execution you can clear all, no need to go for the separate command, because already we have the CLC and the clear all, close and command is are there. So, I can run the command code directly. So, now the CLC command has been worked out. So, it has been cleared, this space is cleared. See, now this space is also going to be clear after executing the clear all. So, 1500 epochs, so up to 1464 epochs. So, results are being. So, now see, we have got the new set of values in the workspace window, and if you could see that maximum 1500 epochs, and it has been executed for 1464. And if you see the performance curve, the performance curve will be, see, the error is very minimally reducing, because it is a regression problem, right. So, that is why, see, if you could see that graph, then it is very easy for you to understand this. See the one with the cross symbol, the one with the cross symbol is the observation. That what is meant by observation? That is actual output. Actually, we have this output. And what is the network output? The network output is one that is produced by. See, if you could see this data point, see, this is around here. See, the round is predicted around 35 point something, and this cross symbol is the actual observation. This is around 35. Likewise, we can take. So, the error difference between these two, we may take it. So, what is the error? Testing error, it is 0.04. That is the predicted value as well as the actual value. The error difference is 0.04, the mean square value of those collective errors. So, in order to do the prediction, or in order to solve the regression problem, there is a small change. Everything is same until here, everything is same. Only you have to use this regressor equation in order to plot the points. So, the plotting points you have to plot with the help of y2, that is the actual output, and r, that is the regressor. So, this is the way you need to understand the predictor value, what is that value, what is the actual value. So, the same thing can be modified for prediction. So, we have seen 4 kind of applications, and 4 kind of applications are meant for doing the classification task, 2 application with respect to engineering and medical, as well as 1 application is meant for understanding the prediction task. I hope the MATLAB code development with respect to the backpropagation neural network model is very easier for you nowadays, and it will be very helpful to do the coding, and for this sample code you can utilize it for developing your own model, The first and foremost task is you have to identify the data from your problem domain, make the data, prepare the data according to the suitability of the code that has been discussed here.